Now let's generate the bootstrap samples, and first let's arrange the coefficients in the same order as the inputs. Okay, we have input A, B, and C going left to right, whereas the coefficients here are going right to left. So let's set it up. Okay, so we want B sub the intercept first, and then B sub 1, right? And then B sub 2, and then B sub 3. Okay. So once we have the coefficients set up in the same order as our samples, then we can say bootstrap sample. Okay. And that will be your intercept. Okay, let's make that absolute reference, plus these three values multiplied by the three inputs, and we can use some product for that. So the slope coefficients must always come from here, so we can press F4, and then these three. Okay, so that will give us the y hat value. Okay, but that's not sufficient for us because we want a sample, so we need to add to this, all right, risk normal, right, 0 comma the standard error of estimate. Okay, so again that should be absolute referenced. Okay. Okay, so now we need 30 of them. So how many we have? 27. So now we have 30 of them. Okay, make sure that that goes to the last row of the sample. So now we have the bootstrap sample. Okay, so let's put an underline border. Okay. All right. Now we can set up our linest function for, okay, let me put it let's put it here. So this is results of linest function for bootstrap sample. Okay, so let's get rid of that. Okay, so now we need to go up to here, and then here, and then we do linest, right? Known y are these, and the known x's are these, and then we do 1 comma 1. We can true, 1 is true, 0 is false, so 1 comma 1 is true. Okay. Now here is where, if you have the latest version of Excel, you can simply press enter. Otherwise, you have to do Control Shift. Keep the Control Shift depressed and then press enter, and that will give you the results. Okay. Then let's run the simulation now. Okay, so set up the parameters. The settings should be automatic for multiple CPU and fixed seed of 1. Okay, and we will run 10,000 replications. Okay, and then simulate. Now to run the analysis based on the simulation results, we have to set one more, we have one more step to set up. And that is, we need to, since this is a array formula, we cannot gather information at risk. We cannot specify any of these cells as an output cell. So we're still interested in these. So we're going to have these values set up in somewhere here, for example. Okay, so let's say we need 4. So all right, so once again we need to reverse this. So we go I, right, 71, and then H 71, and then G 71, and then F 71. Okay, so these are the coefficients, right? So this is B sub 0, this is B sub 1, and B sub 2 and B sub 3, and we also need S of y given x equal to, so that would be G73. Okay, all right, so now we can come up with BS forecast, bootstrap forecast, right, is, no, it's the same. We have the intercept plus some product, okay, of these slope coefficients. We need to do an F4 of that, and then these are the inputs, and then we have to add risk normal 0 comma that one, and make that F4. Okay, okay, so that B2 to D3 should be B2 to D2. All right, so now we have the forecast, and we can run it through. All right, and we can then compare the regular forecast. So this is the bootstrap forecast. The deterministic forecast would have been that without the risk normal, right? So let's take that part. Okay, and set it up here. Okay, let's expand. So this is deterministic forecast. Okay, let's reduce the number of decimal places. Alright, so that would be that and that. So okay. Alright, so now if these are forecasts for the existing data. Suppose we have a specific set of inputs for which we want a forecast. Say we have 6 and 25 and say 20. Okay, and we want a forecast for that. So our deterministic forecast will be that okay, so that, and instead of B2 to D2 we'll have that. Okay, so without normal, so that would be the forecast with the deterministic model. Now with the forecast, with the simulation model or bootstrap forecast is going to be that one. Okay, again instead of B2 to D2 we'll have that. Now let's make this also an output. Okay, so that way we can look at the standard error distribution. Okay, so now run the simulation. Okay, so now we've finished simulation and you see the distribution for S given standard error y given x, and then we have the distribution for our bootstrap forecast, and and of course deterministic forecast doesn't change, it's just a constant value. So if you have multivariate data, then you set up first one LinS to find the deterministic estimates, and you use the deterministic estimate and the standard error to develop bootstrap samples, and you set up a LinS for the bootstrap sample to extract the coefficients and set up those coefficients outside, make those output, and then find forecast based on that. And that's the procedure for simulating and analyzing parametric uncertainty in the relationship between all the x's on the one hand and y on the other hand.